Alright, sorry I had to pause there for a second because I have trouble recording this in segments longer than 6 minutes. So, hopefully you found that area. If not, talk you through it a little bit. Um, it's not 240, so hopefully you didn't do 24 times 10 and make the mistake of just doing length times width or something like that. You're going to have to use some trig. So you have to draw on an altitude again. That's the key step on here. Ignore the 24 for a minute. Just look at this little right triangle. This is the hypotenuse. You're trying to find the height, which is opposite of the 37. Which trig ratio would you use? Trying to find an opposite, and you have the hypotenuse. Sine, cosine, or tangent? Hopefully you're thinking sine. Sine of 37 is equal to h, this one, over 10. Do some calculations on that. I believe it ends up being 6.02. Now you've got your height. Now you can multiply by the original base, which was 24, and you should get an area of 144 square meters. So if you found that, fantastic. You love it. If not, go back and relook at it. Did you apply some trig on there to get that value? All right, the last shape we're going to look at is, and it's kind of hard to see on the screen here, I can tell. Sketch a diagonal in here. So literally you're going to take a parallelogram and you're going to chop it in half. You could easily prove that these two triangles are congruent and therefore it's half the space. That's why your formula for triangles, as most of you know, is 1/2 the area times the base. Sorry, 1/2 the base times the height. I don't know what I'm talking about. So you've seen this formula before. You may not know why. It's because it's half of the parallelogram formula. And it would make sense if you took a rectangle over here and you chopped it in half this way. This would also be half. This triangle would be 30 square feet, and the other triangle would be 30 square feet because it would be half of the original area. It kind of makes sense. It also applies to any parallelogram or any triangle, whether it not be a right triangle or whether it is a right triangle. So I'll give you the example that goes with that one. I'll give you a 20-degree angle on the bottom left. I'll give you the base, being very generous, is 8 units. And I'll give you a second side, 7 units. I'm not going to give you any more angles. Not going to give you any more sides. I will tell you that's not a right angle. Don't assume it's a right angle. There's no right angles on this. This is a non-right triangle. You may want to pause now and do the problem on your own. Or you can just listen to me blab. And then I'm going to draw an altitude in there. Think about how you find that altitude using some trigonometry. Maybe you apply some sine ratios or cosine ratios or tangent ratios. You're again trying to find the opposite side. Ignore the 8. The 8 is the entire length here. We don't want that. We do have this one, which is the hypotenuse of this little triangle. So maybe you're thinking a sine ratio again. Sine of 20 degrees is equal to the height over 7, the opposite over hypotenuse. I got 2.39. Hopefully you get something like that. And here comes the most common error. If you get an answer of like 19.2, you may figure out what you forgot to do. Most common mistake is people forget to divide by 2 or take half of their answer at the end. So if you get 9.6, fantastic, great work. If you don't get 9.6, you probably are getting 19.2. You're probably doing 2.39 times 8, and you're forgetting to divide by 2. Don't forget that. I'll try to remind you again. Alright, the next step of this is a postulate. Looks a lot like the angle addition postulate. Looks a lot like the segment addition postulate. This one's for area. And it basically says you can add areas that are next to each other. Just like angle addition, you could add angles that are next to each other. Segment addition, you could add segments that are next to each other. This just says you can add segments that are non-overlapping, which just means they're adjacent. They're not sharing any space. So like this trapezoid that's on your paper is actually going to be cut up into a rectangle and a triangle. Find the area of this one, find the area of this one, add them together. Same thing with this one over here. I want you to find the yellow. So I don't want to include the blue or magenta or whatever that color that is. Don't find these 4 corners or subtract those 4 corners off at the end or calculate it without finding those areas. So in this case I'm going to call that area subtraction postulate. Same idea though. So as you look at this one, this little rectangle is probably pretty easy to get. 8 by 9. Area of that would be 72. The triangle, you got to kind of borrow some dimensions. The base of this, of course, would be 9, because it's the same as that 9. It's a shared side over here, or a parallel side or parallelogram side. So that's 9, that's 9. This little piece, you'll have to use the 8 and the 13 to get that. Which, if you look at my calculations, I believe that's 5. So area of the entire yellow would be 8 by 9, 72 for this piece. This is a triangle, so I'm going to do 1/2. That's actually my base times my height. So 9 times 5, 13 minus 8 is 5. I think you get a decimal for this, around 22.5. Sum those together and you get, what, 94.5, 94.5 units squared, or square units. So that's area addition. This would be area subtraction. I'm going to show this two ways. You could do this little rectangle broken off, this rectangle, this way. It could be just 5 rectangles, including a square in the middle. So the square in the middle would be a 5 by 5 square, if you can see that. Each of these little rectangles is 5 by 2. It's a height of 2 and a width of 5. So an area of 10 plus 10 plus 10 plus 10 plus that square in the middle. I believe it all adds up to 64 square units. You may want to pause that and go, what? And redo that on your own, or rewind that and see what I did there again. Another way to do this, which I think makes sense to a lot more people, is to find the area of the big rectangle. Think about this entire length, or this entire length. 5 plus 2 plus 2 is 9. Add this whole thing up, you get 9. The original rectangle is 81. It's a 9 by 9 rectangle. You are going to subtract 4 of these little squares off of it. And of course, each of these squares is a 2 by 2 square. So I'm going to subtract 4 of them. And each one's a 2 by 2 square. I believe this is 16 you're subtracting from 81. If you were to do 81 minus 16, you get 65 square. You get the same thing either way. This is using area subtraction. This is area addition. I mean, they both get you the same answers. There's certainly other ways to do this. If you see it differently, do it your method and try it. It might often work out. Check your odds in the back if you're doing work out of the book. Compare with somebody if not. I'm going to pause again here and record this to make sure I don't lose anything at this point.